Lesson 5.4 is modeling. I would pause the video and write down these notes. So a model is a suitable mathematical representation for a situation. Extrapolation is using a model to estimate a value outside the range of given data, and interpolation is estimating a value within the range of a given data. We talked about that in chapter 6. So this is the modeling process. You have a real-world problem and you develop a model. So then you test the model, and if it doesn't work, you reject it, and you repeat this process until you accept the model. You reflect and you apply, and then if you need to extend, so if you're developing like a larger problem, then you go back and you repeat the process. Here's a little diagram of like interpolation versus extrapolation. So the pink points are data points that you were given. So interpolation is if you want to model within certain data versus extrapolation is without or outside the data. So here is some data that represents a chemistry experiment. Liquid is heated and the temperature is recorded at different times. And then here are the results. So here's the time in minutes, here's the temperature in degrees Celsius. So using your graphing calculator, plot a scatter plot for this, and then choose an appropriate model. Like for example, are you going to use a linear model, a quadratic model, so on and so forth. Determine a reasonable domain and range based on the data that you're given. Use your graphing calculator to find an equation for the model. And then use your model to estimate this information and comment on anything from that part. So go ahead and pause the video and try this. So to plot the data on your graphing calculator, you go to Stat, go to Edit, put L1, have your X's, and L2 be your Y's. Then go to Y equals and make sure when your stat plot 1 is turned on, make sure it's blacked out. And then you can either adjust your window, or if you hit zoom 9, which is zoom stat, it'll automatically adjust your window to match your stat plot, so you can see your scatter plot. So then if you look at it, it's almost perfectly linear, so I would choose a linear model for this. Domain and range, the domain is exactly what we have here. The smallest we can go is 4 and the largest we can go is 10 because that's the data that we're given. And then same thing with the range, the smallest we can go is 130 and the largest we can go is 369.2. So then I use my graphing calculator to create the model. You could have also done this by hand, but since we've already talked about doing it with this graphing calculator, that's the way I did it. So I went to Stat, Calc, number 4 is linear regression. Your X list should be L1, your Y list should be L2, or whatever you have up here. And then if you want to store the regression equation, because that way we can plot it on our graph automatically, you go to vars, Y vars, function, and Y1. So then we end up with Y equals 39.905X minus 29.51, where Y is your temperature and X is your time in minutes. And then comment on your model. The R value is almost 1, so it is almost a perfect positive correlation. It's a very, very strong positive correlation. So if you haven't already done so, go ahead and pause the video and use your model to estimate the temperature of the water 4.5 minutes into the experiment and the temperature of the water 20 minutes after the experiment, and comment on those predictions. So if I plug in 4.5 in for X because that's time, you end up with 150.1 degrees Celsius. If you plug in 20 for X, you end up with 768.6 degrees Celsius. So comment on the prediction. I is a good prediction. 4.5 and 150.1 are within the domains and ranges that we said were a reasonable domain and range. But double I is not, because this is an extrapolation. X equals 20 was not within the data that we collected, so we can't, it's not very strong. It's not a good extrapolation. It's not a good prediction. So this has been modeling with linear functions. Use the data you have, create a model, and then make predictions based on that model.